Carmen is here nodding, so that's a good sign. So yeah, so my name is Ronan Collins. I'm the digital engineering lead for HSS Engineers, Malaysia's preeminent engineering company. I've been with HSS for about a year now, and my primary objective is working as the BIM director for MRT3, and I'm currently looking at other projects with HSS as well. So today I'm going to give you a kind of a whirlwind tour of what's been happening in the digital space and construction over the last 12 months, but through the lens of someone who's got 25 years of experience. So as Denny is saying, feel free to interrupt. We've got an hour. I've got about 60 slides, which normally take me about half an hour to get through. So get on the mic or get on the chat and feel free to interrupt. I'm quite happy to field questions as we go. And the more questions we get, the more interactive this is going to be. So let's get started. So three key things to bear in mind before we get into the actual depth of the presentation. The first one is, based on research over the last, certainly the 18, 24 months, it's quite clear that BIM is not used on many projects. In fact, it's used on less than 25 projects, 25% of projects. And for a guy like me, that begs a huge question. For me, part of it's cost, part of it's a lack of understanding, part of it, people think it's new, which I don't believe. So there's a reason that it's not happening. So we've got to figure out, why is BIM not as kind of relevant as we thought it would be? And then if everybody's excited about AI, how do you unlock the value of AI combined with BIM if people are not using BIM? So a lot of the presentation I'm going to share today is a lot of the new technologies are founded on people using BIM. And if you're not using a model-based strategy for your projects, you're going to struggle to unlock the value of BIM. So you've unlocked the value of AI. So you've got to figure out a strategy that gets you to the point where you can use the tools available, but you've got to get the right foundations. And my argument today, you'll see, is that AI is going to propel some firms forward and others are going to struggle. So you're going to see this split in the market between those at the front of the market who are heavily invested in digitalization, and they will start to gain the benefits far quicker than others. You're going to see the middle of the industry trying to figure out how to catch up, and then you're going to find the usual laggards. So this is not for everybody, but AI is going to rapidly change those who are ahead of the posse, and it's going to be hard to catch up. So it's an important thing to figure out. So throughout my presentation, I'm going to use a timeline from when I graduated from university in 1996, which means I'm now giving away my age. I'm nearly 50 years old. I started my career working for Arup in Ireland. In 1999, the time of the millennium bug, if you like, my first experience of BIM and 3D modeling and construction 3D work was in actually a project in Germany. For the Expo, I was the manager for the Irish Pavilion as a structural engineer. So that was my first exposure to 3D modeling. In 2000, I moved to Hong Kong and I joined ARPS in Hong Kong. This is a picture of me standing at the top of IOC2 during construction when I was younger and a bit thinner. And then in 2003, after spending a bit of time working for ARPS, I started my own business. So since 2003, that's when I've really started my journey into BIM. And I was an advocate for technology and construction since then, and there's a picture of my office. So that kind of sets the scene to my career. I'm a civil engineer by graduation, but I'm a technology expert in construction. So in 2003, I set out a company to use detailed models to reduce construction costs and ensure buildings were completed on time. And what's interesting is in 2003, I thought I would have maybe 5, maybe 6 years and the industry would catch up. And here we are 20 years later, and we're still trying to get the industry to catch up. So here's one of the things I want to get across, is that the BIM world is going to be transformed by the software companies, and it's also going to be transformed by the users. So how does it look comparing what was done 20 years ago to what's going on now? So this is an image. This is actually a couple of slides I found on my archive from a presentation I gave in 2005. And I could give this, well, I am giving this presentation now, but it's just as relevant. So in order for you to actually say that you've got a BIM process or a BIM thing, you need to have initial models. So you've got to have your structural models with as much detail as possible. You need to have your mechanical models, again, detailed out. And also you need to have all your risers, your pipe systems, your fire sprinkler systems. It's all going to be modeled up. And those models can then be what we call federated into a combined model or a central model. So when you put all these elements together, you then end up with what we call a complete 3D model of the structure. And then you can start getting value from that model. So the first thing you'll be able to do is identify coordination issues. So this is a very simple animation from a 3D CAD model of a pipe interfering with a ductwork. But you can see that 20 years ago, this was possible. So again, it's just to argue the point that BIM is not new. It's been around for quite some time. Go slightly forward to 2007, when the actual term BIM, or building information modeling, became kind of a bit more commonly understood. And the difference here is that the models were generated by the consultants. So you've got structural models, architectural models, building services models, and then you can have specialist systems. And those models are used to do the design first. You do your coordination, you sort out your difficulties, and then you produce the drawings. So the argument in using BIM properly is that you model first, draw second. And then you can also produce things like quantities, schedules, costs from the model. But the model becomes the focal point of the project. Again, that's not happening on 75% of projects today. So why have we gone in 20 years from no projects to only 20% of the projects? And the other thing that came out of this presentation, which I thought was quite interesting, was the first time I'd seen this term BIM manager. So this is a role where the manager is basically managing the process of generating these models, and you have teams of people supporting it. So, but these are not separate. These are the structural team, the architectural team, the building services team. So what's the difference between 2003 or 2007, that time frame, and today? And what's the impact of AI? So back in those days, we used AutoCAD 3D modeling. We used things like Civil 3D, the forerunner to Civil 3D, and we even started using the forerunner to Revit. And now what we're looking at is, what is Autodesk doing? And Autodesk is the preeminent vendor in this space. So when it comes to BIM tools, Autodesk is the behemoth. And they've announced in the last 12 months a new platform called Forma. And this is basically going to transform, or in their minds, transform how we operate in the industry. Because what they're going to do is they're going to move away from a file-based system to a database system. So it's all going to be driven by data. Now, Autodesk are going all in on Forma. And you can tell this by the way they're recruiting. So they've got advertisements out at the moment, and it's quite clear they're going to bet big on AI. So what are they doing? So what they want to do is they want to change the way that we, the industry, are going to capture information, use that information, and exchange the information. And being Autodesk, they want to control that arena. So they want to be in the space where they're actually doing all of that capturing and analyzing and exchanging. The way they talk about this in Autodesk speak is they're going to empower our industry by transforming how we, the professionals, are using data to capture knowledge, inform our decision-making, and deliver projects. So Autodesk are moving in on the data space, and they want to use data as the backbone. They don't want to use models. They don't want to use files. They want to start setting up this granular data on which everything else is based. And so if you want to learn more about what's going to happen in the space of BIM and AI, then you need to study Forma, and you need to watch what's going to happen with Forma. But what's interesting is Autodesk are talking about a 7 to 10 year time frame. So their roadmap for this technology is not quick, it's not short, it's long. And they believe that it's going to take a long time to get the industry to catch up. So they're not trying to do this quickly, but they are going to be doing this for the long term. And what's interesting is, from an AI perspective, the lessons that we're learning now about ChatGPT and the security of information, the rights to information, the IP in the information is going to become a critical issue for architects, engineers, and contractors who deal with Autodesk, because there is a risk that when you start putting your information on their systems, they're going to leverage it for their benefit and their profits. So it needs to be done carefully. So that's BIM and AI. And I say, I'm going to race to this. So if you have got questions, do interrupt me. I'm going to step into the next domain, which is construction planning. So again, using a slide from 2005, this was the reason I got into BIM in the first place, was the idea that you could link the construction planning information, effectively a Primavera P6 schedule or a Microsoft project schedule, to a model. And so you could take all the tasks in that construction sequence and simulate what that would look like in a building sequence. So again, a very early simulation of what this would look like. This was done to prove the concept. So we basically took a model and then we linked it to a construction sequence. And here you can see the installation of ductwork inside the building, while you can make out the installation of the curtain walling on the outside. So again, this is 20-year-old technology, but it's not used on projects today. And you have to wonder why. Why are contractors not using this as a kind of a normal process? So in terms of this technology, in terms of BIM, we call this 4D or 4-dimensional. So you're basically adding time to the model. And this can be useful across a number of domains. So again, I'm sitting here in PMCC's office, and they're a very well-known project management company. They deal with project scheduling on a regular basis, if not their daily day works. So you can use 4D at the early stage of a project during design. You can use it during tender to understand a project and do some construction planning. You can definitely use it during construction. It's very good for safety planning and site logistics. But more often than not, we're seeing it used in claims. So it's used for claims of what was actually planned against what actually happened, and then recording what happened in design changes. So I'm going to show you an example that we worked on a couple of years ago on a stadium project, just to give you a sense of how powerful this tool is. So this was a stadium in Atlanta. It's called the Atlanta Falcons Stadium, or some people know as the Mercedes-Benz Stadium. If you get a chance, look it up on YouTube. The roof on this thing is incredible. It was designed by Bjorn Happold, and it opens like a camera lens. It's got an aperture. It's 30 stories up in the air, and it's 23,000 tons of steel. And we use 4D just to plan the erection of the steelwork. So we had used technical structures to do the detailing for the steelwork, and then we used the 4D modeling to actually plan the erection of the steelwork. And the reason being that the craneage is quite complicated. So this is an image from the model. You can see there's a lot of steelwork that has to be partially erected on the ground, and then it has to be lifted into place. So you need cranes for the erection of the steelwork in the laydown areas. You need cranes for the steel assembly, and then you need cranes for the actual erection of the trusses in the air. So we used the 4D model to actually come up with a plan in terms of temporary works, site logistics, deliveries, et cetera, of the crane. So you can use these tools for very effective construction management. And this is just a little excerpt of what that looks like. So you can see in this sequence the erection of the roof in the multicolored steelwork up in the air. And as the video progresses, you'll see how it gets much more confined as the project goes ahead. So here you can see the erection of the towers. And then you're going to see a lot more equipment turning up on the site. So at one point, there's going to be 7 or 8 major cranes inside the works area. Some of those cranes are doing initial assembly, and some of those cranes are doing actual installation. The great thing with this project, it was very well documented. So if you really want to see what they were doing and look at it in a lot more detail, there's a lot of videos on YouTube of the actual sequence of works, and I'm going to show you one snippet in a second. So we used this 4D sequence to actually work out the crane locations, work out the method statements, everything else. But we did it in a process that's very manual. So every time we wanted to change a sequence, we had to update the schedule, we had to update the durations and schedule, we had to update the number of cranes, and we had to go and change the simulation. It took a lot of effort to figure out in one kind of scheme whether it would work or not. And where AI is going to make a difference is AI can run hundreds of thousands, if not millions of iterations very, very quickly. So I'm going to show you what this looks like in the real world, and I'm going to show you how AI is going to change how we do construction planning. So that's just an example of what the sequence model looks like. And just to show you, oops. Oh, Carmen's shaking her head. I forgot to do one thing. I forgot to turn on my share sound. Hang on 1 second. So even the technology guy gets it wrong sometimes. Let's try that again. All the cranes getting stood up in the air to build the steelwork. So you can see here the complexity of a building like that. These are unique buildings. This was a $1.5 billion US ego project. So the people that build these stadiums are the billionaires in the US economy, and they're all showing off. But the important thing here is that it doesn't have to be a complicated project to use these kind of tools. Obviously, they're useful, but the idea of using a model and a link to a schedule to do planning is critical. And in the theme of this presentation about how AI is going to change our world, I want to bring your attention to one technology called Alice. Alice is a technology that's coming out of the US. It's been around probably kind of, people have known about it in kind of general terms in the last 3 years. They've been at it for the last 5 or 6 years. It's a rule-based system that relies on a model. So if you don't have a model, you can't use this Alice tool. And it does explore millions and millions of options. So it will go through a whole bunch of scenarios about how you can do this. And it will disrupt the industry. Now, it will not be for everybody. It's not the cheapest technology in the world. It's an expensive tool to use. But if you have a very sophisticated way of managing projects, if you've got tight resources, and if you've got constraints of many complexities, this is a tool that you should be looking at. So I'm going to show you an example from the UK where they're actually using it on a railway project, and it will give you a very good flavor of how Alice is actually used. So I'm going to hand over to the guys who are on the Alice project.
Hi, HS2 is high speed 2. It's the second high speed line that the UK's invested in. It's reducing the time to move between major cities and hubs. This is quite a complex job site over a big area. So we've got a 3.4 kilometre viaduct, which is going to be the UK's biggest viaduct. And we wanted to use a tool like Alice Technologies to help us model and understand the complexities with all the constraints we had.
HS2 will be the fastest rail system in the UK. The structural constraints we've got are phenomenal. The optionality model is very exciting because it gives you a lot of opportunity for scope, for analysis, but also it gives you some good data in terms of how it affects time versus cost and the sequencing on the deck as well.
Software providers that are already in the market are offering small functionality changes, but what this is doing is really turning it on its head in a lot of senses. There's the kind of old guard way of working and sort of standard software packages that we would all know how to use, and Alice is offering an alternative view.
The other software that I've used is Microsoft Project and Primavera 6, which as planning tools are only as clever as really what's been input into them. They don't have an artificial intelligence facility where Alice, you can input the model, you can input the recipes and your desired sequence with constraints, and it actually builds the best way for you to carry out the works. As we've applied and trained our staff to utilize this, we've been able to get substantial improvements in our programs. This software is something they can trust and utilize.
We moved into this multi-dimensional area where we could see lots of dots on the graph of cost and time, all with its own program with a different way of doing it. And that really made our management team sort of really sit on the edge of their seat and go, wow, this allows a different sort of level of conversation to take place. It's brought everyone together on one platform to then really discuss different ways of doing it. It's really helping us to work more collaboratively and more openly in our planning.
We're utilising Alice recipes, capture a very diverse amount of knowledge we've got across our teams. The more information you feed into it, the more accurate the whole model gets.
There's a clarity in being able to define that's exactly how we're going to build it in this exact sequence with these exact resources. We can just tweak and modify the recipes, but essentially that knowledge is captured.
So this new approach really has opened people's eyes to a faster way to do planning and to explore all options. The Alice team have been really supportive to us, and they're not just software experts on Alice as a platform, they're experts in construction as well. That's been a really great experience.
There you go. That's a free advertisement for Alice Technologies. So going on in terms of the timeline, again, do interrupt me if you've got some questions. I'm going to just jump a bit further into my career and into the complexity of BIM. So obviously, as the years have gone on, the projects I've got involved with have got far more complicated. 2007, the company was on a winning streak. We expanded. We opened a new office here. You can see the Guayla or the Matsale making an offering to open our new office. So we expanded our business in 2007. 2008, I met my wife, which is the main reason I live in Malaysia. My wife's from Malaysia. So we met back then. And at that time, I was working on a huge project called the Cathay Pacific Air Cargo Terminal in Hong Kong, which I'm going to show you a few snippets of. But this is probably the project that was the first real project of doing BIM. And it brought up a huge number of issues around engineering management, design management, and model management, which I'm going to show you. And I'm going to show you some of the tools that I would use now if I was doing this project in 2023. So the model was started at the design phase. The owner made it very clear at the beginning of the project that the only way to build this building was to actually design it in 3D. It's such a complicated building with so much complicated equipment inside of it. It's hard to imagine doing this with two-dimensional drawings. This is actually the only digital twin slide in my presentation today, and this was from 2007. Some people think digital twins are new, but they've been around for a long time. This is a simulation of the operation of the air cargo facility. This is actually based on the flight schedules and the expected cargo loads that were going to come in and out of the terminal. And the simulation was basically used to verify the design of the actual cargo system. Effectively, what we have is a building that's wrapped around a cargo system. The cargo system is what it's all about. And if the cargo system is not working, it doesn't matter how good the building is. So the entire cargo system was simulated. I think they did a 10-year simulation based on expected flight simulations, expected cargo. And then once we knew we had enough rollers, enough storage, then we would design the building around it. So a digital twin is effectively the same thing. A digital twin is supposed to be running the operations and being able to manage predict the operations. So I'm not sure what they're doing now, but I know the entire system is automated. So it's all being computerized. Going back to the base building, we use Revit structure to design the frame of the building, and the building is substantially huge. It's actually huge. It's 20-meter grid. and the structures are, in some cases, 1.5 meters deep. So it's a very, very large, very, very robust structure. And we managed to make sure that we did some fundamental things at the beginning. So we started to classify objects, and you'll hear me talking about classifications as we go through the presentation. It's a key part of the AI. If you don't have data classification, you can't unlock AI. There was a bit of architecture. Given this was an industrial building, it was primarily driven by engineering. And you can see that the building contained a lot of mechanical services, fire being a huge issue, smoke evacuation another issue, electrical supply was a massive concern because the whole thing was automated. And if you have a fire sprinkler system, you've got to have a drainage system because sooner or later the fire sprinklers are going to let off. And when you put all that together, you end up with these very complicated, very congested MEP systems. And one thing that we set up on this project, and this is back in 2007, was a very robust classification system. And that was done for two reasons. One was for quantification. So we wanted to be able to use the model to quantify as much information as possible, but also to be able to run analysis. So we were able to use it to run clash analysis. We were able to use interference analysis, but classification was critical. And then once we had the modeling done, we would use the models to produce drawings. So our team set up the entire process around how the engineers built the models, how the draftsmen used the models to produce drawings, how the engineers checked those drawings, how those drawings got sent out for construction. Our team managed that whole process, and there's a lot of planning required. So it's not just a case about go away and build a model in Revit and then press a print button. You have to think through the entire process. So here you can see some examples of cutting sections to these models. This is effectively a 2D drawing. This is the cross section, and all of the stuff that's on the screen is automated. So if you set up your model correctly, there's very little CAD work required. You're always going to require some CAD work, but if you can set the models up correctly, you can get the annotations automated, you can get the dimensioning automated, all the line work's automated, so you can spend your time doing engineering and reduce your time on drafting. But that only happens if you plan out the process. And what we see happening more and more often is that people don't spend time planning their templates, and you end up wasting a lot of time. So one of the things that we set up in that project, and again, it's always fun to go back and look at slides from many, many years ago. This is actually the process that we set up to produce drawings. So we had a server in the office. In 2023, that will be on the cloud. People would use something like ACC. But in those days, we were server office based. So you had to go into the office to do work. You couldn't work from home. All the drawings were produced as CAD files from the models. And then those drawings are then published into PDFs and non-editable DWFs that were sent out to the contractors. Now, if you're familiar with the PAS 1192 or BIM Level 2 standards or ISO 19650 standards, this is what it was intended to be. There was a controlled environment from production, there was a controlled drawing production environment, and there was a publishing system. And when you look at the folder structure, it looks just like that. There's a live environment, which is what we call now work in progress, and there was a published environment, which is what information was actually issued for certain purposes. And inside that are all the different disciplines. And even then you can see we had a naming system. So we actually had a naming system set up in the project. So we had something like 2,500 drawings for the contract design stage. And that basically was an early adoption of BS 1192. So we followed BS 1192 loosely. BS 1192 became PAS 1192 in 2013, 10 years ago. And then in 2018, the BSI and the European Standards Authority issued the ISO 19650, which is the current standard for BIM and information management of projects. And if you think that projects only have 25% of BIM, I suspect that probably 10% of that are following ISO 19650. So the actual standards that are in the marketplace, readily available, easy accessible, are only being used on a very small number of projects. So in order to use AI, my argument is that you also have to make sure you're following the best practice and the best standards, because the software applications are based on these standards. And in the absence of these standards, if you're just running amok and doing your own thing, you're not going to be able to unlock the benefits of AI. So I just want to share with you one of the most interesting things I've noticed in certainly the last 5 years, the way that people change how they're doing coordination. This is a clash detection matrix. It's a basic way of looking at coordination, and it prioritizes certain systems over other systems. I'm not going to go into the details, but I just want to show you that in those days, every single clash had to be done individually. So you had to check the fire system against the structural system, level by level by level. And then what that would do is it would generate hundreds and thousands of snapshots, basically images of a problem. So you can see here, there's a particular clash. And in this case, its ductwork is hitting against a major piece of concrete. The ductwork's in the wrong place, it has to get changed because the concrete's not going to move. So the mechanical engineer has to go and fix it. But in those days, I would have to print out a very long report and give it to the mechanical engineer. And then he would have to try and figure out where the hell this was in the building so we can go back and fix his design. And we would generate these reports. There would be thousands of these issues, and some of them would be small, some would be major, but communicating them with the design team was a real challenge. So what's changed between 2007, 2008, and now? I think the biggest change are tools like Revisto. There's a number of these tools in the marketplace, but Revisto is probably my favorite tool in this space. And Revisto has changed the game primarily because they've focused on the communication side. Identifying problems in a model is easy. Documenting those problems is easy. Getting them fixed is very difficult. And the only way to get them fixed is through better communication. So I'm going to show you a little clip of a promo from Revisto, and you'll understand how they're going about it. But you can see the difference between what I was doing 15 years ago and what the market is, what's potentially available in the market.
Revisto is an integrated collaboration platform that solves these challenges by providing a single source of truth, accessible from any location and any device, and can be leveraged by all disciplines and trades, regardless of technical skill level and whether they prefer a 2D or 3D environment. As an integrated collaboration platform, it takes full advantage of the digitization of the AECO industry, from parametric modelings, BIM data, reality capture, and field technology. Revisto empowers users with an accessible, multidimensional model, allowing for a streamlined, proactive approach to issue and clash management. Project teams can work together across disciplines to identify, track, coordinate, and solve clashes and issues days, weeks, and months before they're built out on site, all in real time and from a single platform. Users can instantly communicate on tasks and address challenges together, and can be confident about the data and models in hand for better and faster decision-making. The project dashboards empower teams with a high-level project status, with granular details to understand exactly what needs to be done to keep moving forward. Revisto provides a new level of accountability, offering full transparency and better understanding of tasks and individual responsibilities.
So that's a tool that is a game changer when it comes to model coordination. What doesn't come across in these videos I'm sharing with you, because these are marketing videos, Revisto does not work out of the box. You have to figure out a system you're going to use. You got to configure it, and you've got to make sure you've actually planned how you're going to deploy Revisto. So it's not a case of go and buy it and use it. You need to have someone who actually understands the core model coordination process. So again, if you're thinking about using Revisto, I'm quite happy to share with you some do's and don'ts and some tricks to make sure it's actually successful on your projects. Now, moving forward, this is where I think in the next couple of minutes, you're going to see where AI is going to have the most immediate impact in construction. And I'm going to share with you some experience from 2009 and how things changed in 2019. So again, using my favorite project, the Cathay Pacific Cargo Terminal, here you can see a picture of the thing under construction. Hong Kong Airport is in the background. If I took this photograph now, there'd be another entire runway behind that because it built a third runway. But this is the project halfway through construction. And the problem that we had in those days was verifying the installation on site compared to the model. So we'd done a lot of coordination in the model. We'd figured out where a lot of things need to be placed, so we didn't have any major coordination issues or delays. But then making sure that things were installed on site in the right place was difficult. And the only technology we had available at the time was basically digital cameras, which rapidly became iPhones. But we would go on site, we would take 10, 20, 30, 100 photographs, and then we go back to the office and we try and figure out for each of these photographs where we were, and then we'd look at the model and compare them. So we would basically do a visual comparison between the site photographs that we got from a site walk against what was happening on the job site. And then we try and figure out if the pipe work was in the right place, if it was installed in the wrong place, if the duct work was in the right place. It was very visual. It was inaccurate. And it was difficult to do, but we did find a number of issues and we did solve a number of issues. So it was an important process, but linking the model to the construction site is a real challenge. Unlocking that is a massive value. So if you can find a way of taking a model where you've done all the engineering, you've done all the coordination, and bringing that to the construction site and being able to check what's happening in the site in real time against the model, it's a game changer. And that technology wasn't available in 2009. We had photographs, but in 2019, when I worked on MRT Line 2, we started developing an augmented reality solution to do just that. So I'm going to jump 10 years from 2009 to 2019, and I'm going to show you a technology that I was heavily involved with at Gamuda. So this is a Gamuda initiative. This is called BIM AR, and it basically links the model to the construction site using iPads. So what you have is you have on the actual iPad device, you have a model for a particular area of construction. We don't have the entire project in here. We have areas of the building because the iPad's got a limit, but you can put the model into the iPad, and then from that you can go on site and actually see the model in the site context. Now, there's a number of use cases for this. The first case is basically verifying that future equipment installation is going to fit where it's meant to fit. So if there's an opening required in a wall, if there's a support required, that it's actually installed before you start installing the next phase. In this example, you can see that we were checking for penetrations for pipework to go through the walls. So these two are obviously, you can see the penetrations in the background. There's one missing here. So we identified there was an issue. This would then get raised as a ticket for the guys on site to fix. They would have to go and core something, et cetera, et cetera. Now, we started doing AR at this level. So we started doing it for checking for openings for MEP. But then the engineers on site quickly figured out, well, hang on, why are we waiting to pour the concrete? Why don't we check the rebar? So when they started, so rather than waiting to pour the walls, they started using the same tool to actually work out, okay, are the openings actually in the formwork? Is the rebar actually detailed for the opening, et cetera, et cetera, et cetera. So they were able to use this augmented reality tool to reduce a huge amount of work on site because they would build it once and then they would have to install. Now, there's two challenges in this. The first one is you need to have a model, because if you don't have a model, you can't use this kind of process. And the second challenge is that model needs to be finished and coordinated, because if the mechanical guys start moving the pipework around, well, then the pipework's still going to have a problem. You're still going to need to core an opening. So you need to make sure that you've got a proper model management process. You cannot use these tools if the model is not good enough and if the model is not actually coordinated. So again, it looks great, but there's a lot of processes behind this, a lot of quality control behind this before you can unlock this potential. And one of the things that we did here, you can just see that you can add in a lot of detail. So here you can see a huge amount of information that can be actually put up on the screen. So that was 2019, jumping back to 2009. 2012, I got married, and then I started working on the next airport project, which is the Midfield Concourse. And this is where laser scanning, drones, effectively what we all now call reality capture, where that became really obvious in terms of a value proposition. So this is, again, the Midfield Concourse. This building is massive. And what's interesting on this one is that the owner or the project director on this, he came up with the term, BIM is not actual building information modeling. He called it best if managed. So he looked at this through the lens of a project manager. So this is the Midfield Concourse project. You can see the key to this building is that the roof steelwork has actually got exposed bottom chords. So that for those of you who are engineers will understand the term a chord, but the bottom of the truss is actually a curved steel pipe that is painted and is actually visible inside the airport. So the next time you're in Hong Kong airport, if you're in this terminal, you can look up and you'll see all these white bands. They're actually the actual primary structure. And a couple things I want to show you here. This is the MEP coordination example. This should work. Here we go. So that's the design model. And I'm just going to show you one of the challenges that we have in the BIM world is that the design model is not buildable. And what you have to do is you don't have to work. Oh, where did that go? Oh, it's hidden behind. There we go. You have to then work with the contractor to come up with a shop drawing model. And this is what you need when you start using tools like augmented reality, when you start using reality capture. You need a buildable, coordinated model. And the more detail that's in that model, the better. So again, if you think you've got a model from a design consultant, if you're a main contractor, you have to think long and hard about how you're going to get to a shop drawing standard model. It's not a case of just taking the design model and going out and job site. It's not going to work. And the reason I say that is there's a lot of coordination gets done by the subcontractors in terms of these congested corridors, in terms of the hangars, in terms of setting out, and being able to make sure that what actually gets installed in site is the same as what was actually coordinated is a big challenge. So it needs to be done by the construction teams. You cannot rely on a design consultant to work this out. They just don't have the experience and the knowledge, and they don't have the time to do it either. So looking at the actual roof, because that's what I want to talk about today, the roof is actually quite a straightforward structural system. But again, just to give you a comparison, that's the design model provided by the design engineer. This was an Arab Mott MacDonald project. And that's the design model. When you get to fabrication, it looks a lot different. And the reason it looks a lot different is a lot more detail for things like secondary connections, for things like walkways, for hangars. In order to be able to fabricate the steelwork, the fabricator's got to do a lot more detailing, which is not the responsibility of the designers, it's the responsibility of the contractors. And then when you layer into that all the stuff that's hanging from the underside, you end up with this massively complicated model around with structural connections for ceiling systems, for walkways, and eventually for MEP systems. So again, this is a tool that contractors get most value from. And then you've got the cladding system. So just from beneath, this is the same roof from beneath. So you can see the structure, You can see the mechanical systems, and in some areas it's quite dense. Then you can see the ceiling system, and then eventually you get to the ceilings. Now, when you've got exposed structural steelwork, you need to know it's in the right place. And I don't know anybody that can survey this with a measuring tape and a total station. The only way to survey this was to actually use laser scanning, which was new technology back then. So our objective was to figure out, could we actually use laser scanning to survey the steelwork, and would it be valuable? So this was the job site. We sent out the team, and they did a point laser scan, or point cloud laser scanning. So they used basically a total station with a laser device on it, and they captured the steelwork position. And then we had to figure out a process to allow us to actually compare the point cloud scan from the job site to the actual models that were used from the fabricators. These are the actual fabrication models. Now, of course, I'm going to show you an example of where it was in the right place, but in some cases, the structural steel was out of tolerance. But here you can see a comparison between a point cloud model and the structural model. Now, back in that timetable, 2010, 2012, that time frame, so 10 years ago, the amount of processing power required to do this was massive, and it was very slow. So we had to do it one trust at a time, and it proved to be very, very difficult. And before I finish today's presentation, I'm going to show you a technology that does this instantaneously, and it's going to hopefully blow your mind. So we did it for the roof, then we started doing it for the air bridges. So we had all this point cloud scanning for all the steelwork. So again, we scanned all the structural steelwork, and we were able to tell if certain structural elements were out of tolerance. So here you can see connection plates that are too high, too low, twisted, et cetera, et cetera. So the green point cloud is the real steelwork on the job site, and the red is the actual detailed or shop drawing models. So here you can see a comparison between the reality capture and the actual models. Now, what I want to do is I want to show you what's happened. Okay, just going back to my family timetable. My son was born in 2014, and we moved to Malaysia in 2016, and I was, as you've already seen, working for MRT Line 2 in 2019. One of the other things we did at the MRT was actually using drones to capture information. So here you can see basically, let's see if it's going to work. This is a 3D model captured by drones. This is the Bandar Malaysia North Station. So this is actually a model. It's compiled from photographs captured by drones, and it's every month of the construction process. So you can see from this imagery the progression of the works. You can see the tunnel machines being launched. You can see the excavation progressing. And this is a very powerful way of recording what's happening on a project. And because this is a very accurate model, we can actually use it to measure quantities. We can measure depths. We can quantify things. So we can identify numbers of equipment. We can identify material delivered on site, et cetera, et cetera. Here you can see the TPMs being launched. So this is a game changer when it comes to actual site surveying. By flying a drone every week, you can actually capture what's happening on the job site. And some of the use cases when it comes to BIM is, if I get this to come down, no. So you can then use this model. So this gray model is actually generated from images that were captured by a drone flying about 20 meters above the job site. So you can see the actual drone images in the top right corner. But what you can see is a comparison between the actual base level of the structure for the station against the excavation quantities. And you can see there's a bit of a TBM popping out here. You can see the actual slab being cast in the base of the excavation. So being able to compare what's happening on site to what's going on in the models. If you think about it, this was 2019, 2020. 10 years earlier, we were taking an image and trying to do a desktop study. And in 2019, we could actually compare models to models, real models from the job site against models from the actual BIM. And this is where AI is going to step in, and it's already doing it. So what I'm going to show you is where AI fits into this. So now we're up to 2023. My son is now 9. I'm getting old. And in his lifetime, we've gone from using models and photographs from a camera to using AI to do comparisons between design and construction. And there's a number of tools out there. So QPix is a solution that's coming out of Korea. It's a very, very powerful reality capture tool. There's another one called Reconstruct out of the US. OpenSpace is a tool from the US that's quite common. Nazca is the one I'm going to show you in a second, and Alice I've already mentioned. This is just a handful of AI tools, and these are the ones that are going to change our industry in the quickest timetable. So these tools are going to be the ones that you're going to see the most of in the near term. And so this is Nazca. I'm going to let these guys explain what it is, and then I'm going to come back in a second.
We are capturing data on construction sites using devices like the BOK2Go, which is really as easy as just walking around this device in your hand. You don't need costly surveyors to be able to capture all that information. Walk around, capture that high quality data, upload all of that to the cloud, And then what you have is raw data that our computer vision and machine learning algorithms then go to work on. We do recognize that we do not operate in a vacuum. We're not solving all your problems. We are just one portion of this ecosystem, and we're a platform that opens itself up to all of those inputs. So model data should live in ACC. Laser scan data, hey, that should come from Leica, that should come from Cyclone. We just take all the information that is already available, we process it, and then we deliver it back to you as an additional level of information. We're leveraging the investment that you have already made in these platforms and to gather all this information. So we take that and we turn it into actionable information that you can then use to make better decisions on. So we take every element in the BIM and we automatically classify it. So gray means no data, not enough information to make an assessment. Green is verified. That means it's within tolerance. That's obviously, it's good. Red is missing, so that means that it hasn't been installed. That's not necessarily a problem. That really depends on context. And then orange is out of tolerance and has not been built correctly. And then that lighter yellow color is under construction, which means that it's halfway between being built and not being built. This means that we can immediately flag up risks on your project. Here, there's a penetration, there's a block out, it's missing. I can immediately see that it is in fact actually missing. Here, lift shaft, it's telling me it's deviated, it's been flagged up. I can visualize that deviation in 2 seconds, and I can see that the lift shaft doors are the wrong size, they're missing material on the top. That's obviously a problem. Get out ahead of that. Here, this steel column, it's missing. That's obviously not great as we're moving the project forward. And in literally seconds, I can flag all those risks up to the guys on site who are then able to make better decisions with that information, all hosted in a web viewer. Just in terms of concrete ROI, this is from a different but similar size project. Within 1 month, we quantified that we caught 94 critical deviations on that project and saved them approximately $1.5 million within 1 month, just by providing better information to make better decisions.
So that's the business case for AI right there. So basically, before we get to Q&A, I'm just going to summarize some of the stuff we've touched on today. I think you'll agree that from the kind of stuff I've shown you between where I started my career and where we are now, it's not for everybody. And that's why you see a disparity across the industry. You're going to find some companies like the Gamudas of this world, like the Arabs of this world, who are invested in these technologies and will get value from them. Everybody else is going to struggle. So in order for you to get to the point where you can compete and actually win some work, I've got a 3-dimensional solution for you, 3 Ds. The first thing you need to do is you need to define the problem or issue you're trying to fix. Do not go out and buy technology because you think it's cool or because you saw it on my presentation today. You first of all need to define the problem that you've got. Then you need to develop a plan of attack, identify the KPIs that you're going to measure, and work out what potential solutions are in the marketplace. So if you want to do reality capture, do you use Qpix or do you use something else? If you want to do coordination and clash detection, do you use Visto or use something else? And if you're going to pick those platforms, how are you going to do it? How are you going to set it up? Who's going to manage it, et cetera, et cetera. And then once you've done your development plan and you've come up with your plan of attack, then you come up with your deployment plan. So you deploy it on a project, you have to train the staff, you got to provide support to those people, and you got to evaluate their process. So in order for you to actually unlock AI, you first of all got to unlock BIM. And in order for you to unlock BIM, you've got to follow my 3D plan. So you got to define the problem, develop your plan of attack, and then deploy it on a project. And then if you need help with that, give me a call and I'm quite happy to share my experience. So that's my presentation today. I hope you've got something from it, and I look forward to the Q&A.